We're now going to look at adding and subtracting common fractions. So I'm going to start off with the example of 3/8 plus 1/8. Now if we think of 3/8 in terms of pizzas, we're looking at a pizza that has been cut into 8 slices because the denominator of the pizza is 8. And then the numerator of the pizza is going to tell us how many slices were eaten. So we're going to shade those in, and we're shading in 3 slices. If we look at the other one, because the denominator is also 8, that means that that pizza was also cut into 8 slices. But in this case, looking at the numerator, we only ate 1 slice. So if we look at the answer now, we see that if the pizzas have been cut into the same number of slices, it makes it very easy for us to realize how much we've eaten altogether. So the denominator will remain the same as 8, and we see that we've eaten 1, 2, 3 from here and 1 from there, so that gives us a total of 4. We needn't have drawn the diagrams because we can see that 3 plus 1 is 4. So if we look at 4/8, that is our answer, but if we think back to our previous video on equivalent fractions and simplifying fractions, we can give this fraction in a much simpler form. So if we think of the HCF of 4 and 8, what is the biggest number that can divide into 4 and 8? If I divide the top by 4, I also have to divide the bottom by 4, and so therefore my final answer is going to be 4 divided by 4 is 1, and 8 divided by 4 is 2. So in effect, even though I was presented with 2 pizzas and I ate a bit from the one and a bit from the other, in effect I ate half a pizza. Now it doesn't always work out that the denominator and the denominators are the same, so let's look at a situation where they're different. We cannot add those 2 fractions until we get the denominators to be the same. So now we go back to what I taught you in LCM, the shortcut to find the LCM, which is the lowest common multiple, and here we're finding the lowest common denominator, which is basically the same thing. So remember, we had to look at the bigger one and consider that number, and then ask ourselves, does the smaller number divide exactly into that number? 3 can divide into 6, so therefore my denominator is going to be 6. So what I like to do is I like to just set up the fact that I found the correct denominators. My common denominator is going to be 6. So in this case, the denominator was 6 and it's still 6. If the denominator doesn't change, then the numerator isn't going to change. But in this case, the denominator was 3 and now it's 6. So how did I get 3 to become 6? I multiplied it by 2. And whatever I do to the bottom, I must do to the top. And so my numerator here is going to be 1 times 2 is 2. Now I'm back in this sort of situation where the denominators are the same. And if they are the same, then I can go ahead and write down the denominator and add the numerators. 2 plus 1 is 3. So again, this is the answer, but it's not in its simplest form. So I'm sure you can see that both these numbers belong to the 3 times table. So the HCF is 3. And so I can say 3 divided by 3 is 1. And 6 divided by 3 is 2. And there I've actually got the same answer, but from a different sum. All these things that I do in red are things that a lot of you will do in your head, but I'm writing them down so that you can see what the thought process is. Let's have a look at 7/8 plus 5/6. Right, again we've got a situation where the denominators are not the same, so we're going to use our shortcut of finding the LCD. What is the bigger denominator? 8. Can 6 divide exactly into 8? No, it can't, so I have to go to the next multiple of 8, which is 16. Can 6 divide into 16? No. Carry on to the next multiple. Can 6 divide into 24? Yes. So now I just set up my sum as being something over 24 plus something over 24. Right, now to find my numerators. In this case, both denominators change to become the LCD. So how did 8 become 24? I multiplied it by 3. Therefore, I multiply the top by 3 and I get a numerator of 21. How did 6 become 24? I multiplied it by 4. Therefore, do the same to the top. And 5 times 4 is 20. Right, if my denominators are the same, I write down my denominator and I add my numerators. So 21 plus 20 is 41. Now, if we have a look at that and we think back to my first video on fractions, this is a fraction where the numerator isn't smaller than the denominator like it was over there. The numerator is larger than the denominator, which means that it's an improper fraction. And the best way to give your final answer for an improper fraction is to remember that 41 over 24 actually means 41 divided by 24. So how many times does 24 go into 41? So if we count in 24s, we've got 24, 48. No, I can't use 48 because it's gone past 41. So 24 only goes into 41 once. Now we need to work out what's left over from 41 if we've used up 24 of the numbers. So there are two ways you can do that. You can count on, or you can do a little sum on the side with in columns, subtracting 24 from 41. Let's try counting on. It's so quick once you get used to the method. So if we're counting on, we don't want to count on in ones because that's going to take us a long time. So first of all, we say how many from 24 to 34. That's 10. So keep that in your mind. And then we've got to count on from 34 to 41, which if you count on your fingers, if you're not very good with your bonds, will give you 7. Remember, we already had the 10, and now we've also got 7. So that is 17. Remember, your leftovers, your remainders go on the top, and the denominator will still remain the same. So that looks like quite a weird looking fraction, but everything's fine. I've got my whole number part of my mixed number, and the other part of my mixed number is a common fraction. Right, let's have a look at 9/10. And this time, instead of doing addition, we're going to do subtraction, and the method is actually exactly the same, except at one point you're going to subtract instead of adding. So looking at my two denominators, 10 and 4, which is the larger one, 10, so I start with that. Can 4 divide exactly into 10? No, it can't. Go to the next multiple of 10. Can 4 divide exactly into 20? Yes, it can. So now all I'm going to do is write down that I'm going to be working with something over 20 minus something over 20. And now I go to finding out what my numerators are going to be. 10 became 20 by multiplying it by 2. So do the same to the numerator, and I get a numerator of 18. 4 became 20 by multiplying it by 5. Do the same to the numerator. 5 times 3 is 15. And now my denominator has to remain 20. And looking at my numerators, I've got 18 minus 15, which is 3. I've got a common fraction because the numerator is smaller than the denominator. So the only thing I have to check is, can that common fraction be simplified? There was a common fraction and I was able to simplify it. So the question I ask myself is, do these two numbers belong to the same times table so that I can divide them both by the same thing? No, they don't. So that is going to be my final answer.